Imagine diving into a world where particles pop in and out of existence, fields create and annihilate, and the fabric of reality itself dances to the tune of uncertainty. Ever wondered how particles like electrons and photons interact with fields, creating the symphony of forces we observe? Have you ever wondered the incredible depths of quantum fluctuations that underlie our everyday reality? Well, today we are diving deep into the fascinating world of quantum field theory, one of the most captivating and mind-bending subjects in the realm of physics. In this video, I am going to introduce you to what I believe is an absolute gem in the world of physics literature, a book that is like a guiding light through the complexities of quantum field theory. So whether you are an aspiring physicist, a student, or simply someone with a passion of understanding the deepest workings of reality, this book is an absolute guide to understand quantum field theory. My name is Shaunak and you're watching this video on my channel Physics for Students. Welcome to this fresh video, the best book on quantum field theory, the book that teaches you everything. Well, before we go ahead and look into the content of the book, here is the objective why I am making this video. Well, first of all, what I would like to tell is that this book I would like to give you a complete, honest and unbiased review of this book. This is my first objective, so that you can understand that it is a completely unbiased and an honest opinion as far as my opinion and decisions are concerned. The second thing is that this is such a wonderful book that you will understand a complete overview of quantum field theory. The third one is that you will come to know that after that, where will I go, what to study, what are the next book or what are the next mathematics that I need to study, what are the physics that is lacking and what I need to do. And lastly, I would say you will have to fill in the blanks with your mathematical skills, because we will look into real mathematics of quantum field theory and you will find there certain gaps, and as you know where to go, then you can fill in the blanks with your mathematical skills. All those 4 points which I have told, I have clearly explained in this video how to select the right book in mathematics, what to check, what are the do's and don'ts. If you have not watched, go and watch this video, which would be good for you when you are selecting a book, when you are perplexed and confused which book to select. So I will be following those parameters which I explained in this video and go ahead and explain this book. But before that, I would like to warn you, just on a lighter note, a note of caution. Now, what do I mean by note of caution? First of all, you must understand that quantum field theory requires some serious prerequisites. That means you have to know special relativity, electromagnetism, statistical mechanics, calculus, relativity, group theory, and a very, very solid understanding of quantum mechanics. You also will be encountering lot of mathematical complexities. There will be issues, problems regarding what we call is a renormalization, where we deal with infinities. Quantization of fields sometimes become very complex, and you also have to deal with the interactions of perturbation theory, and these, because all these things lack practical experiments, so we have to understand what is called those abstract concepts, and it is really time consuming, and it has got very limited resources and textbooks. Now, don't get demotivated. I'm just willing to tell the real reality, that these are the things which you will encounter. These are the problems. These are the things which you need to make up your mind. That is, it is time consuming. There are less resources, and due to lack of practical experiments, you have to prepare your mind for what is called abstract ideas. Now, the good point is that in spite of such a wide spectrum of mathematical knowledge that you need, maybe you won't be able to understand 100% of this book, but even if you understand 40 to 50 or 60%, you are much better than normal people who understand quantum field theory, and you get a much more deeper understanding of that. So this book, which I would be now talking about, is more in a holistic approach of a quantum field, and this book actually aims for a better preparation before you jump into the complexities of quantum field theory. So in one way, this book is a complete holistic idea, and you really don't need to go anywhere else if you read this book. And even if you feel that, okay, I don't understand all those mathematics, if you understand at least 40% of it, you are done. You know quantum field theory better than anything. So without wasting further time, let us look into what is the book that I am talking about and what are the further details that we'll come across. Okay, so the name of the book is this one, Quantum Field Theory, Basis in Mathematics and Physics, and it is written by the German mathematician Eberhard Seidler. Now you see the Amazon rating more or less gives a rating of 5-star, 56%. I think this should go up to 75 to 80%. Now this is the details. It is by Springer. The language is English. The country of origin is USA. And you see the number of pages already exceeded 1000. So the publisher is Springer, and the date of publication, as it shows, is 13th of August 2009. So I hope you can understand from this is what the book is all about. So once we see that this is more than 1000 pages, we understand that it's quite an extensive book, contains lot of information, and it is if the book is quite more in number of pages, that means it aims that you don't know anything, and that is the basic idea of a book which will teach you right from the beginning. Now before we go ahead, check the content and other details. First thing is that who is this person, Eberhard Seidler? As I told that before you select a book, it is important to note who is the person, who is the author, and what is his credentials. Here is a quick idea about the author. Well, Eberhard Seidler is actually a German mathematician working primarily in the field of nonlinear functional analysis. He began studying mathematics at the University of Leipzig, and in 1996 he became the first managing director of Max Planck University Institute, and he gave up the management but remained as a director. He was a great scientist but also a great human being, always concerned with the well-being of others. Now remember that because he's a German author, at the beginning of the book he has apologized for his not being a native English speaker, but you will find the book to be absolutely fantastic. Okay, so if you really want to know more about Eberhard Seidler, this great mathematician, this is a link in Wikiwand which you can go and check, and you can find out more about his works. However, Max Planck Institute has already paid a tribute, and because he passed away in 2016, and Springer Lake also has got in memory of Eberhard Seidler, and you can check the details of what this is all about from this two links. So this is a little bit about Eberhard Seidler, German mathematician, writing this book, quite a well-known, well-respected professor, and these are the two links through which you can check. So he has got numerous publications and papers which you can go, and I have not mentioned unnecessarily, the video will be too long. Okay, now remember one thing, that the book that we are talking about is not just one volume that completes the entire quantum field theory. There are several volumes which we will just look into it. The first volume which we are talking is the Basis in Mathematical Physics. The second volume, written by the same author obviously, is on quantum electrodynamics. The third book is on Quantum Field Theory 3, which talks of gauge theory. So these are the first 1, 2 and 3 volumes, but we would be going right now with the first volume. But wait, we are not done yet. We have another volume which is called Quantum Mathematics. I'm sorry, I cannot find out the book in internet. I contacted a few of my professors also, but I cannot find out. If you do find the soft copy of that book, or maybe the cover of that book, you can just let me know. The fifth volume speaks of the physics of the standard model, and the sixth volume, quantum gravity and string theory. I think, if I'm not wrong, that these books are actually not printed. I think he was working on that and he died before of a protracted long illness. Now, this is something which is very important in this book, is that you see what it writes in this book is that this is the first volume of a modern introduction, and this is for both mathematicians and physicists. And you see, I have underlined in red, the book tries to bridge the existing gap between the different languages used by mathematicians and physicists. Now, this is truly important. This is actually shows the basic sense of the book. Now, you see, if there are two kind of Obviously, the mathematicians would be doing their own mathematics with their symbols and deep mathematical intricacies. Physicists will be there, but what the mathematicians tell and what the physicists tell might be they are two different, and it is very sometimes become very difficult to understand each other. So here is the bridge, and this bridge actually bridges the gap between the language, the basic essence, and the basic aim of the subject. So what Professor Zeidler has done is that the mathematicians, when they are speaking of quantum field theory in one way and physicists speaking in another, this book is exactly the gap. Now what does that mean? I will just show you. This actually will show that whether you are a mathematician or a physicist, this book is an eternal guide for you. Okay, so let me give you what is the essence of the book. What do I mean by the essence of the book? Now you see, the book, what he writes in the first is that I have noticed that many of my colleagues in mathematics complained about the fact that it is difficult to understand the thinking of physicists and to follow the pragmatic but frequently non-rigorous arguments used by physicists. On the other hand, my colleagues in physics complain about the abstract level of modern mathematical literature and the lack of explicitly formulated connection to physics. And here he writes, it is my intention to build the bridge between mathematicians and physicists. This is the basic essence of the books, because Professor Zeidler himself found that there are mathematicians who are complaining what physicists are telling, and physicists are complaining what the mathematicians are telling, and this would be basically the gap. So if you're good in mathematics, great. If you're good in physics, great. This book will serve both the purpose. And here you see, this is very, very important. I've just taken a snapshot from his preface that for students of mathematics, I would like to show that detailed knowledge of the physical background helps to motivate the mathematical subjects and discover interesting interrelationships between quite different mathematical questions. And for students of physics, I would like to introduce fairly advanced mathematics, which is beyond the usual curriculum in physics. So being this the essence of the book, that the students in mathematics, he tries to show that a detailed knowledge of the physical background will help you to learn more about mathematics. And for students of physics, he would like to introduce some fairly advanced mathematics so that the physics students can understand very well. So you understand, this is the basic essence of the book. So we come now to the table of contents part 1, but before going that, I would like to tell the viewers is that this is a 1000 plus pages book. Obviously it is not possible for me to give a summary of each and every page or so on, so I'm giving a brief overview, but that will be again very detailed and exhaustive. The first table of contents starts with a historical introduction. Now I would request all of you, this section is very important, and until you read this section you will never understand what is quantum field theory, what is the objective, and why quantum field theory came into being. So please do not skip this section. The next part is that this section covers almost 250 years of limitations of theories and how QED came into being and what are quantum computers. So the left hand side of the screen you can see quantization, role of Göttingen, Nobel Prize, lot of information. This gives a fairly important, clear and exhaustive understanding. Here are the things which deals with it. So you can see the entire historical background from Planck's radiation hypothesis, Einstein's special relativity, standard model, quantum numbers of elementary particle, fundamental physics, symmetry breaking, parity violation, CP violation, everything is covered. So this part actually covers the evolution of quantum mechanics and until it reaches the stage of standard model. Each and every concept has got a summary which is written in italic. I will just show you, and the mathematical notations which the Professor Zeidler uses is fairly descriptive and very easy to understand. Say for example, this is what he is trying to explain. 3 general principles for elementary particles. The principles of indistinguishability, the Pauli exclusion principle, and Pauli's spin statistics principle. And here you see he writes in italic. That means this is a quick summary, very easy to understand. The color charges of quarks is a consequence of the Pauli exclusion principle. So every part of the paragraph you will see is being ultimately summarized in italics, which becomes very easy. Say for example, the sum rule of spin of quantum numbers. Again there is a historical remark. How beautiful. That means the spin rule of quantum numbers is not clear until you understand the 1927 Stirner-Gerlach experiment and what it actually tells. Even not that, the quantum number of leptons, if you see these particles, the Q, P and L, this has been elegantly described right below what P total means, what L means electron and leptons, what B means the baryon number, and all those things. So this actually shows how beautifully and well arranged this book so that you really don't face any problem. We move to the second part, which deals with the fundamental role of symmetry in physics, and he speaks basically of classical symmetries. As you can see, translation, rotation, space reflection. That means what? He's going step by step from the classical to the quantum world. And here you see he has introduced what is the symmetry, the space translation, rotation, Lorentz transformation and everything. So it is clear, absolutely crystal clear, and the table structure gives you a complete summary. The author introduces the concept of conjugation, parity transformation and time reversal. Now here you see he concludes that the Maxwell equations are invariant. We know that under the transformations of C, P, T and T. You will see what C, P and T is that once you follow those indexes. Now this is obviously, this is special relativity. We know that Maxwell's equations are invariant under transformation. Now you see this is a theorem which he does. The Schrödinger-Maxwell equations are invariant under gauge transformations. Now you see there is something very important to note. He uses this concept, the covariant derivatives. So let us, I have underlined this, let us introduce the covariant derivatives, or we generalize the classical partial derivative of the wave function psi. So that means what? That you need to have an understanding of covariant derivatives earlier. You need to have a covariant understanding, because he directly introduces what is a covariant derivative and shows the Schrödinger-Maxwell equation which is invariant. So you should be careful about that. Symmetry breaking has been divided into parity violation and CP violation, irreversibility, splitting the spectral lines, spontaneous symmetry breaking parts, and bifurcation and phase transition. This is how it divides. I'm not going to details. It would be better if you read it. Okay, now when we go into physics and modern differential geometry, not much has been told in this chapter. As he mentioned, this will be studied in volume 3 with the modern language of fiber bundles, and he just summarizes this section, obviously telling the emergence of curvature and force is equal to curvature. So 2.9.2 physics and modern differential geometry, not much covered, which is covered in chapter 3. Now we come to the third important point. Remember, this is the table of contents of part 1. That means what happens when the challenge happens in different scales in nature. This is very important. So what he says is that the author takes up the very large scale and the very small scale. And he talks about the problem with the physics that happens when we move from a quantum scale to the scale as big as the Earth's radius. And here he mentions most theories become intractable when they require coupling between even two adjacent length scales. This is what he does. He gives an idea of what happens when the scale changes, and this is what he says: 1, 2, 3, 4 and 5. The singular limit from Einstein's theory, that is a change in scale. The singular limit from the mesoscopic Boltzmann equation to the macroscopic Navier-Stokes equations, again a scale change. Phase transitions of a singular limited to Ginzburg-Landau equation, again a phase change. Film films and singular limits, and thin plates as singular limits of a three-dimensional elasticity theory. So here he introduces what will happen when the things changes. Right. Now what I would like to draw your attention is a very fundamental concept of physics, which is called Wilson's renormalization group theory in physics. Don't worry, I'll just tell you what this is all about. Now, this is actually named after this gentleman, Kenneth Wilson, and what it is fairly simple. He tells that the behavior of physical system as viewed in different scales. Okay, what do I mean by that? I will just come. This was developed by Kenneth Wilson, and it became a fundamental tool in many areas of physics. So let us assume a very simple kind of an example. So for example, when we see a physical system by zooming in on it and then zoom out again, just think of something that we are zooming inside and zooming outside. Now when we zoom inside, we can see obviously all the details, intricacies of everything. But these details can be overwhelmingly difficult because of the intricacies. Now when we zoom out, obviously things become easier, but we lose some of these details, but we gain a broader perspective. So you can see that I have just drawn this to make you understand about Wilson's renormalization. So if this is a forest, and what I do is that when I zoom inside the forest, what I can find is that you will be able to see the leaves, but eventually you will lose sight of the forest as a whole, obviously, when I'm zooming in. But when I'm zooming out, then we can see the tree, the bushes, the ground, I mean to say the individual leaves and everything, because we are getting a more of a holistic picture. So this is what actually Wilson does. So Wilson's renormalization uses this special math to describe how things change as we zoom in and out. That means when we are zooming in, what we can see, and when we are zooming out, what we can see. And this is something important, that sometimes certain things stay the same even if we change the scale. And these unchanging of certain things, like the big patterns, we notice no matter how close or far you are from the forest. So this renormalization method obviously is used in quantum field theory, as you understand, in order to understand how close things are, and when we zoom out, how big things are. Yet something will be invariant, and those things will be required to study in the macroscopic scale and the microscopic scale. Okay, I will show you this one also. This allows us to systematically study how the behavior of a physical system changes as we zoom in and out. Now the question is that why it is important. Now you see that here, as we understand this one, okay, let me go back. So we understood what is zooming in and zooming out. That means the microcosmos and the macrocosmos. So using this, what he tells is that he gives a complete table of energy levels from macrocosmos to microcosmos, and it also shows that different energy scales, and he explains in details the renormalization of electric charge and the basic idea of renormalization of groups in quantum electrodynamics, the determination of the beta function and the running coupling constant, which is for the asymptotic freedom of quarks, the quark confinement, and the proton decay of supersymmetric grand unification is also being covered. I have not shown the table, but you will see that there is a table which shows this Wilson's theory and shows how things in the microcosm and macrocosm, how the difficulties arises in the problems and how we solve it. We come to the table of contents of part 2. Here what I would like to tell is absolutely, and this book, you know, contains a lot of great quotations, and I love literature, so I I'm making you understand, because you can see there's a huge number of quotations, and this is awesome. So you see, this is a folklore which says mathematicians and physicists like holomorphic and meromorphic functions, since the local behavior of such functions determines completely their global behavior. So what does that mean is that holomorphic means as a whole, and meromorphic means something in part or something in small. So obviously mathematicians and physicists like something big as well as something small function, and since the local behavior, that is the meromorphic functions, determines completely their global behavior, so a study of both those things are required. Isn't it wonderful? Second part starts purely with the basic techniques in mathematics. So this is huge, I mean to say really huge, and it give you a complete guidance with all the explanations required, equations, everything, and make you understand about the mathematics of quantum field theory. And remember, it is very exhaustive, but you will enjoy every part because it tells certain wonderful lines and quotations and events from history that you will fall in love when you start dealing. So I'm not going into that level of mathematics. I'm just showing you what it covers. It starts with analyticity. I've read it starts with complex numbers, goes up to power series and Cauchy's integral formula and so on. It covers also a lot into topology, manifolds, diffeomorphism, the Euler characteristic, magnetic fields, everything. Then it goes into many particle systems in mathematics and physics, and then it covers a huge lot of details of Lie algebra, Lie logarithms, rigorous finite dimensional magic formulas of quantum field theory. Left hand side you can see it covers functional calculus, functional derivatives, discrete Feynman path integral, huge. I mean to say I won't be able to read all those. So the magic Gaussian integral and everything. It also covers the rigorous finite dimensional perturbation theory, which is renormalization, the Weierstrass theorem, fermions and the calculus of Grassmann variables, and infinite dimensional Hilbert spaces. Further, it covers the Gauss's method of least squares, integration by parts, the variation problem, the distribution of Green's function, as you can see on the right hand side, the Dirac's formal approach, the Lorentz-Schwarz rigorous approach, and Hadamard's regularization intervals. It also covers Newtonian potential, functional integrals, what is harmonic analysis, followed by distribution in physics, the eigen distributions, high energy limit. I'm going to say it covers almost everything. You don't need to go. So you see, I have drawn a conclusion that it is an exhaustive mathematics that you need for more than 500 plus pages. And this is the entire list, starting from analyticity, topology, Lie algebra, Fourier series, Banach spaces, Lagrange variation of parameter distribution and Green functions, microlocal analysis, Lorentz-Schwarz counterexample, and so on. So what I can tell you is that table of contents part 2, or the content that you would be reading in part 2, is all inclusive, all comprising of the entire mathematics that you need to do, you need to understand. But these are very interesting, very easily written. Each and every equations are well defined and well narrated. We come to the last part, that is table of contents part 3. And this actually is nothing but a summary. So you see, it is a heuristic formulas which covers basic strategies of quantum field theory, then the Fourier transform, what is the psi4 model, the glance of quantum electrodynamics, everything. It also covers operator model, the lattice approximation, the scattering cross section, peculiarities of gauge theories, and so on. So let me give you finally what is my honest review, because I have skipped a lot of it because it's a huge book. It would not have been possible for me to detail out each and every pages. So the first thing that I would say is, definitely after reading 5 books, I can tell you this is one of the best books on quantum field theory. The style of writing is brilliant. The quotations, the small events, the historical contents make it very intriguing and interesting. Even if you do not understand, as I told you, because of the mathematical part, yet you get a very deep and mathematical understanding of quantum field theory. The language is easy, friendly, and intriguing. The illustrations are quite simple and elegant. Apart from that, what I can also tell is that this book assumes nothing. That is why it is huge. That is why it is voluminous, and that is why it contains everything that you need to know as far as the mathematics is involved. This book assumes nothing and teaches you the voluminous mathematics. And here you will see the modular form is discussed, which is again a fitting, because a work of few mathematical physicists who are attempting to show connections between the Lagrange program and algebraic geometry. So yes, this is something which is required. Apart from that, I would also say the treatment of functional calculus is very rigorous, which might again be misleading for some newcomers. And this chapter, especially the rigorous finite dimensional perturbation theory, this chapter is very interesting, and it addresses a lot of issues in renormalization problems and the bifurcation theory. So this is all in all, I would say, yes, it is definitely a must-read book with all the complexities given. The mathematics is wonderful, the literature is wonderful, the historical background is wonderful, and the entire, I would say, spectrum of quantum field theory in one book is covered in a great manner. So thank you very much for those who have watched my videos and taken up time. Please do subscribe to my channel Physics for Students. Click on the bell icon to get all the notification from Physics for Students. You can always contact me at this ID, and you can subscribe to my other channel General Relativity Explained. And further, you can follow me on my Facebook, LinkedIn, Instagram, and Twitter account. So this is the my review and a complete understanding of the book, which gives you everything you need to learn about quantum field theory. I hope you liked. Please do let me know your reaction by putting a few comments in the comment section, and don't forget to subscribe and watch out more, because Physics for Students will be soon back with few more interesting and many more interesting videos. Till then, goodbye.